Hi. While doing the homework for Paul McWhorter's Raspberry Pi class number 45, one of the homework things was if we're also taking the Fusion 360 3D printing classes, was to show off our design if we made one for the Pi cam holder. And I gave a quick look at what I did on my homework video about getting the Pi cam set up. But one of the other students that are taking this left a comment down here. Andrew said, "Really cool. Um, could you make a video on more of the design?" So for Andrew, here's my how I went about creating this design and the thought processes included in it. So I didn't really, like I said, I think I when Paul first asked, I said, well, yeah, that wouldn't be too bad. Just make like a round base and um, put a holder at the top of it or whatever. And I wasn't even thinking about making it integral with the Raspberry Pi. But when you look at it, you got this cable that is only what, a foot long, or maybe you can put your uh, Pi maybe, or your camera about 10 inches above the Pi, and the Pi has to stay there with this ribbon cable. You're not going to go too far with it and everything. You don't want to stretch it. So I said, that's when it hit me, well, you got to have a base, so why not make the base with the Raspberry Pi sit in it? So like I said, you can see here, that's what I got. And also, uh, one of the things I like to do, I love 3D printing, but 3D printing isn't for everything. So this vertical rod here, I originally thought about using just a wooden dowel rod, a 1/4 inch dowel rod, but I didn't have any dowel, but I had a piece of steel rod that was 1/4 inch in my shop. So I used that. So, you can 3D print everything, but it just isn't just, especially if I would have used dowel rod. I mean, you can go buy a foot of dowel rod at Lowe's for probably, I don't know, it used to be $1, probably $2 now for a stick of dowel rod, 1/4 inch dowel rod. But and maybe you got it already in your shop or something. So um, I also use, for structural parts, like if I make a spool holder for my 3D printer, um, I'm not going to go to all the trouble of 3D printing the part that holds the spool part. I'm going to use PVC pipe. Um, it's stronger. It's cheap. You know, you can buy a 10-foot length of 3/4 pipe for a couple dollars, or it used to be a couple dollars, probably $5 now. And you only need it, 6-inch piece of it. So it's next to nothing in cost, where you know, you're gonna have to design something that can uh, hold your spool. And with the layers, 3D printing isn't always the strongest for that. Where you you could put 100 pounds on a piece of pipe, and it probably wouldn't a short piece of pipe, and it probably wouldn't bend it or anything. So um, that's my design goals. So when I was looking at the Pi, I said, well, I don't want to block the ports on it. So that's when I decided to set it off to the side, like I have it off, set offset. And also, when you're setting the Pi in, your headers will be here. So we have that T connector. And I usually you would have to put the breadboard out here. So I said, well, I can spin this around and it'll be facing that way for the breadboard if I ever want to capture the breadboard in my videos. So anyhow, that's what I was thinking. And also, like I said, I knew that this was only going to be 8-10 inches high. I forget exactly what I made it, but let's go over the uh, cam for that and or not, I mean the CAD for that in Fusion. Get myself out of the way a little bit. So there's the holder. We'll go back to the, I'm not gonna redraw this, I'm just gonna go back to the beginning. And so you can always do this, you can edit your sketch. So the first thing I did, I got the outline, used my handy calipers, and I probably could have went online and got the dimensions of the pie and everything. And like I said, I decided that I was just going to make a tray, and I put standoffs because there's some components on the back side of the pie, and you don't really want it to sit on that. So they have the 4 standoffs on here, in here, here, and on the top same way. So I just put standoffs in there and did that. So I measured this line here, as you can see the dimensions for the pie itself, and I always give a 10 thousandths or so clearance when I measure 345. I'll just add 10 thousandths to it just for clearance on almost all parts that I create. And then you can see 230, so it's probably 220 on that. So, and like I said, we're in a, I use imperial units. So in America here, that's what we do. Then so then you had your 4 standoffs that you wanted to be on those bolt holes. So the way I design that or think about that is, okay, I want to get one that's in a corner and I want to measure to where it is. So that's what I do first. I put one here, and I knew that it was 200 thousandths to the center, just eyeballing the calipers. You really can't measure the center of the circle without doing a lot of math. So I just eyeballed it, and it was about 200 thousandths and about 170 thousandths from this edge of the board. So I placed that one, and then I did the same process and measured the distance in between these two, and just come up with that 195 and just place that one, and then went down to this one and got the 225, and then I think I just did horizontal vertical on these to get them exactly right. Same way here, horizontal vertical to get them right, so that they're all on the same line. But basically that's all I did for that. And then you use your offset, and here like I said again, I just offset it 100 thousandths, 0.1 inches. Just that seems to be a good thing to use for just uprights that aren't going to be too flimsy but not too beefy and everything. So also the Raspberry Pi, I found that the connectors are so close to the board that you really can't recess the board down too far. So I think we'll see when we do the extrusion, but these are just probably 50 thousandths less extruded than the sides. So let's go ahead and go to the, I got finished, get the sketch, go to the next one. All right, so that's the first. So the first thing I did, I extruded this, and I extruded it down. Some people don't like to do this because this is the origin plane, but it really doesn't matter. When you 3D print it, it's fine. So I did make the base 200 thousandths thick just to give it some beefiness. So, and then the next one, I brought these up. Let's see, I'm pretty sure they came up 200 thousandths. Okay. And next would be the sides, I guess. And I brought them up 250 thousandths. So yep, they're 50 thousandths. The sides are just 50 thousandths higher than the side of it. And then let's see, then I sketched. All right, so now I'm decided to put that side on. Now that's a kind of a, I don't do things as clean as Paul likes to do them, but all I need to do is make sure I visualize it. So this is where the rod's going to fit. And like I said, it's a 1/4 inch rod, and I knew my rods were exactly 0.25. So with my 3D printer, at least, if I give 10 thousandths, it gives a nice snug fit. It can be pulled out, but it's not easy and it's not sloppy. The rod will stand up good in that. So that's where the hole's going to be. And then I just kind of decided to make something that looked about right with the 800 thousandths, a little over 3/4 of an inch diameter for that. And I could have just made these sides I could have just put sides straight out to that, but I like a little bit of aesthetics in my design. So I just created 2 more circles and did the tangents up against here and up against the other circle. And that way you end up with a nice thing. Now, Paul, he would have went through and trimmed up all this and trimmed all these away and all that, but you really don't need to do that. So, and that's what it looks like. And like I said, oh yeah, one thing I did want to point out on this sketch. Let's go back to the sketch. So the sketch plane was the top of this. So I like to build my sketches just the way I envision it being on the thing. You could have started on the bottom. You could have built it from the bottom, but I always look down on stuff. So I just said, where you want to start your sketch plane, it's going to be on this top layer here. And then when you go and do the extrusion, you just extrude it down. I'm not going to show that, but I just extrude it all the way to the bottom. So if you remember, we started here at the plane and went down 200, and then we came up 250. So this is actually about 450 thousandths, or just under a 1/2 inch high. So when your rod sits in there, it's got plenty of beef where it's not going to tilt side to side too easy, especially if you got a nice tight fit. What did I do next? I don't even know what this is for. Let's edit this sketch. Oh, okay. So if you notice, that sketch is actually on the bottom. So I wanted to go ahead and put in the rod that I wanted to do, demonstration. So I started my sketch on the bottom plane because that's where I wanted this bottom of this thing, which is below this plane. You can see. Well, actually, that's where your plane started. So I said I wanted to start my design, my sketch on this plane here, and that's where it came up. And like I said, I wanted to design that rod, so I just made that 250. I just you pick up the center of the circle and you just make a 250. That's the only thing that was on that sketch, was that rod. And then you go to the next one and you extrude it out. And you just extrude that 200 rod out in 8 or 10 inches or however long I did it. And then you go to your next one and you start this sketch, because this is where I start on the top, and you can start your sketch on the top of that. So I'm going to edit that sketch. And you can see that part, I just said, where you want to start your sketch? I said, I want to start on the top of that. And then you say, I already had my 250 for that, but I knew that I wanted the 260, or I wanted, Actually, I might have made that 250, but it wouldn't matter. But normally I would have made that 260, but it looks like I made it 250, which I noticed it was a little tight going on, but it's still nice and snug for that. I might have did that because I didn't want it to be too loose. So maybe that was a conscious decision. I can't remember. But then I just decided to make this circle about, 600 thousandths, a little bit 5/8 of an inch almost. And then I knew that I needed these things out here for just a couple rectangles. And I just made those rectangles so that they would be there. Like you say, I didn't even fully define this one because it really didn't have to be, as long as it was inside this one when you go to extrude it. But you can see, the important things. I got the thickness of this and the thickness of this. I think I made these equal or something. I don't see a dimension on them. Oh, there it is. It's down there. Having a heck of a time here. There we go. So there's my dimension down there, and I put the other dimension up there. Usually I try to keep them together, and then I have 100 thousandths in between it, so you got room to squish that when you're done. You say, well, that doesn't look like much, but it's enough to give you your extrusion. So we'll go to the next one. So there's my extrusion. And if we go ahead and edit that, that'll bring back up, your all your sketches. So you just pick the parts you want. And like I said, you just don't pick that section when you do it, and everything's good, and extrude it down. So you have to watch whichever way this arrow is going is the positive direction. So when I started, it was facing up, so I knew I had to go with a negative number there. And then you do have to eat, like I said, with each one of these pieces, it's going to be a separate part. You got to say new body, not join. When I was making this, you would say join, but with this, it's a new body each time. So that's extrusion there, so we're okay. Next, I think I put the hole in that, so wow. So yeah. So what I did is, it's actually on this side. I said, I started a new sketch. It says, where do you want to draw this sketch? So I already had this extrusion. This is where I wanted to start my sketch, because this is where I want to put my hole. So I just, all I did was put a 260 thousandths clearance hole there, because I knew I was going to use a 1/4 inch bolt for this. And then we just extrude it all the way through. Then we start our sketch for the next part. Well, I'm not sure what that is. Oh, okay. It is a little confusing sketch here. But that has to do with the camera holder part. And I don't know how you're going to see this, but the camera, like you say, you got all these parts. This is the front side, the back side of the camera. And you can see how close those components are to it. So, I use my calipers, and they're like 50 thousandths clearance on the edge of the boards here is all you have before the components start. But you got components on the backside of that board, so you couldn't, make it flat. So you had to just give a little clearance. And then on the front side of the camera, you still got capacitors or something, some components soldered on the board, but they're a little bit farther in. So I was able to give 100 thousandths on that. So like I say, this sketch has a lot of constraints and everything else on it. But if you see it, you got all these just bunch of rectangles, basically. And like I say, I don't even have the connector in here. I do that on a different sketch, but this is just a sketch. I knew I just wanted an L-shaped frame. And then and I knew what my dimensions were for the outside of the camera. So that's what this dimension here is, I think. And then I added these little, well, I probably did these first. So I put these rectangles in. They are only 50 thousandths wide. And I just set them out 150 thousandths. I didn't mirror this. I think I probably could have used mirror, but I didn't use that on that. So I just drew each one separately, but they're the exact same thing. And then I knew that I wanted this to be 100 thousandths. It looks like it's 100 thousandths by 100 thousandths. And then I didn't even draw. A lot of times I'll put the, the part that I'm trying to do, like I would put a rectangle there for the slot just to make sure that it's right. But I was pretty confident of my dimensions on that, so I didn't do that. And but it's just a lot of different rectangles. Like I said, it is L shape. I think I started out with L shaped design, and I just added a bunch of rectangles on the outside of it just to make it work. So this is the space where your components on the back are going to be, and then this is where the thing's going to be slid in, and camera's going to be facing out. So you just got to think of what you're doing and do that. Like I said, I think it would have been helpful for me to start a rectangle with the size of the board there. And I knew the board was about, 40 thousandths thick. So I wanted it to be a little bit loose in there so you could slide in and out. So it had 100 thousandths and then 150 thousandths. That's 50 thousandths there. So anyhow, that's what I did there. This video is getting longer than I wanted it to be, but I figure I might as well give the whole spiel. So that's what that looks like, the camera holder. So if you notice, right now, there's no bottom in that slot. So I can't remember, is that the next thing I did on the design? Probably put the bottom rectangles. Yeah, I just filled in these rectangles at the bottom and then extruded it. Now you see that little things up there. And the next one is a sketch. I'm pretty sure that would be this connection sketch here. So let's see what I did for that. And this is where, when you get to this point, you probably wanted to start turning off things. So you can turn off your bodies up here. Let's turn off 2 and 3. So now you see this is where I wanted to sketch. So I did this a little different way than you might think, but I did a 260 and then I just did a 500. I really wasn't sure how I was going to do this, but then I more thought about, well, I need to 3D print it sitting on the base here, sitting on the bottom. This is where it's going to be 3D printed from. So therefore, I didn't want to have supports and everything. So all your overhang is going to have to be taken care of. But anyhow, you got that, like I said, you had to have your clearance hole, and then that made 500 thousandths just because. And then I went ahead and extruded it. I extruded the hole through the part, and then I extruded this up. And but I said, well, if I print it from here, that's gonna be an overhang, and I'd have to either support it or something. So I said, oh, let's just put a 45-degree chamfer all the way around that. And it actually, turned out to be, this was printable because it's 45 degrees. And it just, everything worked out like that. So I said, that's good. So sometimes just, like I say, if you got 45 degrees, you're fine. You don't need to worry about much else. And I don't even know. Oh, this sketch here. Yeah. So now I need to put my, I wanted to put a hex bolt in there. So I had to create the hex. So did that on that side and got lucky because I didn't put that bolt hole exactly where I wanted it. And it just worked out that it worked right up to that. So a 1/4 inch bolt in America, you use a 7/16 wrench on it. So 7/16 is when machinists talk, I have some training as a machinist. So when machinists talk about they in America, they talk about thousandths. So 7/16 wrench is 437.5 thousand. So if you ask a machinist what the decimal part of 7/16 is, they'd say 437.5. So that's what this is for. That's the exact dimension. But of course, you want to make it a little bit bigger. So when you're making a polygon, you're doing the radius, so you got to cut it in half. So I got 225. So if you double that, that's 450. So I went from 437.5 to 450. That gives you plenty of clearance. You just don't need that, you don't need your head to be that tight. You just need it not to twist in the thing. So that's what we did there. And move on to the next one. And then extruded it out. Give us a nice hole there. Oh, what did we sketch next? Okay. I got to start turning parts back on. Might as well turn them all on for a second. So I'm not real great at spinning these items. I could get better at it and get by. So now we're working on the knob side. So like I said, this was this side, and then, but if you see when you can just call it a new component or a new body when you do this, but best thing to do is just to draw it because you already got this hole here. That's the best place to start drawing something. So I started sketching, and the only thing I did is kept the hole here and then just made it a certain diameter. And I just extruded it, but I used, let's go and edit that. So when you extrude something, you can extrude it and you can give it a taper angle. So I tapered it out. But if you noticed, I had the hole in there, and my hole also tapered the other way. So the hole ended up being a lot smaller. So I had to fix that on the next one. But I still wanted that shape, so that I used that. And you can see that's a new body, so it's not attached to that. So you say, okay. And the next sketch was to create that hole. I created a new sketch for it, but oh, okay. So I did all this at one time. So I created the knurled part. Instead of making knurls, I decided just to make a circular pattern of circles and have them overlap, but have like a ridge in between them. So this just looked like it was going to be good. And at the same time, I made this center part so that I could extrude that as well. So let's go ahead and what did I do here? Oh, first thing I did was extruded the circle back out, which is good. And then I extruded the knobs back out, so then they came out just fine. Almost done, actually. So the only thing I had to do now was sketch the the nut had to be recessed up into this. I did the same thing, 225.225 radius, or I guess radius, or one's from one center to one side of your thing. So it's 450 thousandths again. And then all I did was recessed it in there. And that's all there was to it. So my workflow is I like to keep building and make it look like it's going to be in the end. I know, you could do this and have all separate parts and everything, and then, combine them up and put them together. But why do all that? You just build onto what you got. And, if I was drawing it on a piece of paper, that's how I'd do it. So, I mean, that's why this workflow just works just fine. Anyhow, Andrew, I hope that was a little bit, I know it was long-winded, but I hope you got a little bit out of it. Thanks for watching. Have a great day.